So today we're going to talk about dividing rational expressions. The last lesson we did was on multiplying rational expressions. Now remember what a rational expression is. A rational expression is where you have a fraction and both the numerator and the denominator are polynomials. So we've simplified rational expressions, which is where you factor the numerator, factor the denominator, and then cross out what's common. We've multiplied rational expressions. Now we're going to divide rational expressions. Dividing rational expressions is just like multiplying rational expressions. Same thing, except there's one slight difference. Before we do that, let's remind ourselves and go back to dividing regular fractions, like we did in junior high. So 5/8 divided by 15/14. Now, if you remember, the way we divide fractions is very, very similar, if not identical, to multiplying fractions, except for one slight difference. And what that was instead of division, we're actually going to change this to a multiplication problem. And to do that, we keep the first fraction the same. The first fraction always stays the same. But instead of dividing, we're going to change it to multiplication, to multiplying. And we're going to take the reciprocal, or where you take a fraction and flip it, of the second fraction. So instead of 15/14, we're going to make it 14/15. So instead of dividing, we do what we multiply by the reciprocal. We multiply the reciprocal. So we keep the first fraction the same. We change it from division to multiplication. And we change the second fraction, not the first fraction. First fraction always stays the same. We change the second fraction and we flip it. We flip it to make its reciprocal. So we multiply by the reciprocal. So instead of dividing, we multiply by the reciprocal. Then we can do like multiplication. We can cross cancel. 5 goes into both of those once and 3 times. 2 goes into both 8 and 14 4 times and 7 times. Then we can multiply straight across. 1 times 7 and 4 times 3. And we have our answer. We're gonna divide rational expressions just the same way. So we're going to change it from division to a multiplication problem. And at the same time, we're going to take the reciprocal of the second fraction. We're going to flip the second fraction. And then it's just like multiplication. Then it's the exact same thing that we did in the previous lesson. So let's look at our first example. X squared minus 9 all over x squared plus 5x plus 6 divided by 4x squared minus 12x all over x squared minus 2x minus 8. So we leave the first fraction the same. We're going to take the reciprocal of the second fraction, so we're going to flip it. So numerator goes to denominator, denominator goes to numerator, and we change it from division to multiplication. So let's factor. X squared minus 9, we can do dots. X plus 3, x minus 3. On the denominator, it's a trinomial without an a, so we are going to find the right combination. 2 numbers that multiply to equal 6, but also add equal 5. That's 3 and 2. Okay, now we're going to change this from division to multiplication. And we're going to flip the second fraction. So we'll flip it and factor at the same time. So x squared minus 2x minus 8, even though it's on the denominator, it will now be on the numerator when I flip it. So we're going to factor that. Find 2 numbers that multiply for -8 but add for -2. That would be -4 and +2. And now this numerator will now be on the denominator because I'm taking the reciprocal. And I can factor out a 4x. So I've factored all 4 spots, both numerators, both denominators. I changed it from division to multiplication, and I took the reciprocal of the second fraction. Now we can cancel out anything that's common. Remember, in order for you to cancel it out, one has to be on a numerator somewhere, and one has to be on a denominator. So I see an x plus 3 and x plus 3. I see an x minus 3 and an x minus 3. I also see an x plus 2 and an x plus 2. So now on the numerator, what do I have remaining? I have an x minus 4. On the denominator, I have 4x. Remember, I cannot cancel out the 4's because I'm adding and subtracting in the numerator, and I cannot cross out the x's for the same reason. There's my answer. X minus 4 all over 4x. Let's do another example. 3x squared plus 24x plus 36 all over 6x plus 9 divided by x plus 2. So we're going to factor the numerator of the first fraction. So we can take out a 3, x squared plus 20, plus 8x plus 12. And then I can factor that down. Find two numbers that multiply for 12, add for 8. That'd be 6 and 2. So that's the numerator. Denominator, I can factor out a 3. All right, so now, instead of dividing, I'm going to make it multiplication. And I'm going to take the reciprocal. Now, the original problem, the x plus 2 is actually over 1. It's x plus 2 over 1. The x plus 2 is in the numerator. So when I take the reciprocal, I'm actually going to flip that and make it 1 over x plus 2. And now it's a multiplication problem. Now that everything's factored, because I obviously cannot factor a 1 and you cannot factor x plus 2, now we can cross and cancel things out. So I see an x plus 2 and an x plus 2. I also see a 3 and a 3. Everything else needs to stay. So on the numerator, I have a 1. You don't really need the 1. So I have x plus 6. On the denominator, I have 2x plus 3. You cannot simplify the 6 with the 3 or the 6 with the 2, because once again, this is a binomial, and so is that. And you cannot simplify just parts of polynomials. So my answer is x plus 6 all over 2x plus 3. That is dividing rational expressions. It's just like multiplying rational expressions, except before you start, you take the reciprocal of the second fraction and you change it to a multiplication problem.